Hello, my dear friends. Today we are going to discuss the relative effects of non-bonding odd electrons and lone pair. This is our topic of discussion of today's class, and it has been seen many times that such kind of questions are being asked. The that is shape of NO2 plus ion. Na2 plus, the what is the name of the Na2 plus? This is nitronium ion. This is nitronium ion. And NO2, this is, we all know, this is nitrogen dioxide. And third, NO2 minus, this is called nitrite. Okay, so if we discuss the shape of these three pieces, then throughout our discussion we can easily understand the relative effect of non-bonding odd electrons and lone pair, and these three guys are of utmost importance in different entrance exam. Okay, so let's start with this guy first, NO2 plus. So before starting the shape of NO2 plus, we are to derive the hybridization state of nitrogen. So hybridization of nitrogen atom in NO2 plus. So this should be H, and here we all know the formula, and if you are not aware of this formula, we are providing the details of the class and link of that class, in which we have already discussed how to derive the hybridization state of the central atom of a molecule. So H is half Ma plus Be minus C minus A. So what is Ma? Ma is the number of monovalent atom around the central atom, that is nitrogen. So here number of monovalent atom around the nitrogen is 0, because nitrogen is surrounded by the two oxygen atoms, which are basically divalent. So number of monovalent atoms around nitrogen is 0, and number of valence electron of nitrogen is 5, and nitrogen here the pieces is cation, so the charge of cation is +1, and A should be 0 because this is not an anion. So here half is 0 plus 5 minus 1, 0. So it gives 2. That means H is 2, H is derived as 2. So that means the participating orbitals, that means the participating orbitals uh, equals to 2. Participating orbitals equals to 2. So hybridization, that means the hybridization equals to AsP, number of participating orbitals 2. So hybridization is AsP. So number of lone pair plus sigma bond, number of lone pair plus sigma bond equals to 2. So to be attached with any pieces, and the number of pieces is 2 around the central atom, that is nitrogen. So 2 sigma bonds will be required, minimum 2 sigma bonds will be required. So number of lone pair equals to 0 and sigma bond equals to 2, because at least 2 sigma bonds are required. Okay, so the shape of the this is the linear shape. So the shape is linear. In case of NO2 plus, the shape of the NO2 plus is linear shape. Okay, and the plus charge resides on the nitrogen atom. So the shape of NO2 plus is linear. The shape of NO2 plus is linear. And my dear students, you are all requested to write down the notes, otherwise you all forget it. And if you do have any questions, you can ask in the comment section. Okay, and all the in our next section, NO2 minus. Similarly, here the state of hybridization of nitrogen is half. So H is basically half. And my dear students, I am requesting all of you to not to skip a single second of this class. If you skip this class, or if you skip any moment, you cannot understand the whole concept. Okay, so try to be with us, try to be with me with the fullest concentration and without skipping a single second. So H is equals to, again I am writing, H is equals to half of Ma plus Be minus C minus A. So in that case, there is no monovalent atom, so it is 0. Number of valence equals to 5. Same again here, but here it is anion, so cation should be 0, and as it is anion, so it is minus 1 charge of anion. So it gives 5 plus 1. So it gives 5 plus 1, that means 6 by 2, that is 3. So number of participating orbitals in hybridization, number of participating orbitals in hybridization equals to 3. So what will be the hybridization? So here the hybridization is sp2. So what will be the shape? The shape is trigonal planar. But the actual shape, this is the ideal shape. We must say this is the ideal shape. The actual shape is different from trigonal planar. So in our next session, we are going to discuss the actual shape. So number of sigma bond plus lone pair. So what will be the number of sigma bond plus lone pair equals to 3, because the hybridization is, so hybridization is sp2. So number of lone pair plus sigma bonds equals to 3. That means here sigma bond equals to 2 sigma bonds will be required. So number of lone pair equals to 3 minus 2 equals to 1. That means this is the actual shape, and here a lone pair bond pair repulsion, two lone pair bond pair repulsion exist. Two lone pair bond pair repulsion exist. Okay, so that's why the bond angle will be 115 degree. So we must say, due to lone pair, BP means bond pair, due to lone pair bond pair repulsion, oxygen nitrogen oxygen bond angle should be 115 degree. So this is less than 120 degree, that is ideal bond angle. This bond angle is ideal. So therefore the actual shape is the V shape. So my dear students, you all understand how to derive the actual shape of the molecules. And in our third NO2, here the state of hybridization is H equals to monovalent atom, V valence electron minus cation minus anion. So number of monovalent atom is 0, number of valence electron is 5. This is not a cation, this is a neutral molecule. So number of cationic charge equals to 0 and as well as number of anionic charge equals to 0. So H becomes 2.5. So 2.5 means number of, that means H 2.5 means H 2.5. What does it means? It means the number of participating orbital equals to 2 and the number of odd electron. Odd electron means a single electron, not an electron pair, an unpaired electron. The unpaired electron, this odd electron, this is unpaired electron. So the odd electron means the unpaired electron. It does not take part in bonding, or it does not take part in pairing with other electrons. So number of odd electron is 1. Number of odd electron is 1. So it is 0.5. Okay. 0.5 means the unpaired electron is half, paired up electron is 0.5. That means the number of unpaired electron is 1. So the hybridization, what will be the hybridization? Hybridization is sp, because the number of hybridized participating orbital 2. So sp is the hybridization state of the nitrogen, where the number of participating orbital is 2, and the shape is like this. And look, the bond angle here, this is 125 degree. Okay, the actual bond angle, actual shape. Why? Because here a repulsion exists. The ideal shape will be like this, the linear shape. The ideal shape will be linear shape, but here the single electron and the bond pair repulsion exist. Okay, so here a repulsion due to, so here repulsion between which, between a single electron, that is the odd electron, and bond pair. Okay, that means the bond angle becomes 135 degree. Okay, so we memorize the oxygen nitrogen oxygen bond angle. It is 180 degree for nitronium ion. Number 2 is 135 degree for NO2, and number 3 is 115 degree for NO2 minus. So my dear students, I hope you can understand something out of this class, and this type of data are very important in in many typical exams, like entrance exam in IITs and NITs and medicals. So my dear students, for this class I think this is sufficient, and I am again requesting you to please watch our channel and be with us and learn something, okay, by paying some minutes. So I am again requesting you to please subscribe my channel and be with us and keep good health. Okay, we will meet again in our next class.